So in this lecture, what we are going to do is to quickly recap some of the stuff we did in the last lecture, and then to understand the significance of some of the key elements of what we derived during the last lecture. So in the last lecture, what we did is to study 1D linear time varying systems. So this is basically your equation dx dt equals atx, where this is a scalar equation with some initial condition of x at t equals 0 is x0. And the solution of this is, as you can have seen, the solution is simply uh, xt is x0, um, phi of t, where phi of t is the fundamental matrix at with and we understand that phi at time t equals 0 is 1. So that's what we have seen. And just for the record, so this is that phi of t is given by exponential of 0 to t a tau d tau. So that's the whole thing is our solution, right? This xt is x0 phi t, where phi t is this exponential of the integral. Right. So that's what we did in the last class, and also we have to understand that this is for a generic time dependence. Now we have to see what happens when for periodic systems, because that is what is more important for our study. Periodic systems, which means say a of t plus capital T is a of t. Um, so it's a T periodic system. And for that, we found some interesting results. The first result was this, that phi, the fundamental matrix, T plus capital T, is phi of small t times phi of capital T. And we can use induction to find that phi of t plus n capital T is phi of t times phi of capital T to the power n. So we call this as equation 3 and this as equation 4. Right. So these were derived during the last lecture. And just a small thing that I would here put t tilde instead of t for reasons which will be explained in a little while. Um, the goal right now is to understand the significance of say, for example, these results, right, for periodic systems. Now, why do we need that, and what is this what we do with this fundamental metrics after with equation 4? So let's see where we use it. It's the solution itself. Um, Sorry, something's wrong here. Yeah, okay. Equation 2 itself says that x of t. So let's define t as n capital T plus tau. Okay, and for that, let's just draw the time axis itself. So this is my time axis. So I start at some time 0. So this is one time period, two time periods, and so say it is n time periods, and this is n plus one time period, and so on, right? And say what is t tilde? Say t tilde is between 0 and capital T, one time period. So t tilde is somewhere, say here, okay? It's somewhere here. That's my t tilde. So equation 4 says that phi of t tilde plus nt. So that means that this is your nt, right? And plus t tilde. So use some other color, red maybe. So this is up to here is nt, and this bit is t tilde. Okay. So phi of t tilde plus nt, where do we use it? We use it in the solution, right? So rather than writing this, let's see. What is x of t tilde plus nt is x of 0, phi of t tilde plus nt, right? Now, So what is phi of t tilde plus nt? It is exponential of 0 to whatever the full time is t, which is t tilde plus nt, a tau d tau. Now we do not really worry about this right now. Okay, let's remove it for now. I'm just putting it just to show. Um, Now the right hand side from equation 4 is phi of t tilde, phi of t to the power n. Okay, which we write as x0 phi of t tilde phi t, right? So x at at the time so much in the future, which is here the red where it ends, right? um, you can you know everything for up to this time by just studying what happens between the first time period and the knowledge of phi capital T. Okay, so with that, because that's all, that's equation, call it the equation 5, is saying that so much down the line in the future, t tilde plus nt, okay, is that knowledge, you can say everything about that from your initial condition, which is x0, right, the initial condition, and knowing about the fundamental metrics for one time period, because if you know about one time period, you can multiply it n times to know about the n time periods, and the phi for t tilde, right? So let's try to see this as an example. Okay, let's take an example. The example is x dot equals, um, let's do it, say cosine, say sine square t x, of course with the initial condition x0, some x0, and what we want to know is, say, and what is the period of sine square t? The period of sine square t is pi. So capital T, just to say that, so capital T is pi, right? So what is phi of capital T is e to the power 0 to pi sine square t dt, right? Okay, and the integral is pi by 2. Okay, the integral point something, just, yeah, it is 5.5, so that comes out to 5.5, but that's not that important. Okay. um, so the next thing what we want to do is, which is to see what you want to know. The question is, say you want to know this equation, you want to know what is the question is, question is what is x at t equals 20.5 pi. Okay, that's the question, and the solution to that would be x at, so you're at, so t equals 20 pi plus 0.5 pi, right? So your n, so your n, this is your n, okay, and this is your t tilde, right? So x of 20 pi plus t tilde, okay, this is nothing but x0 phi of capital T, and you know that capital T is pi, and n is 20 to the power 20. I'm just using equation 5. So, and phi of t tilde, okay, and phi of t tilde, and phi of t tilde is exponential of 0 to t tilde sine square tau d tau. Okay, so whatever that expression comes out to be. So in other words, phi of is, and this t tilde is, how much is t tilde, is 0.5 pi. And just to know that t tilde is 0.5 pi, right? So x of 20 pi, 20.5 pi is given by x0 phi of pi to the power 20. And so phi of pi is this bit is 5.5. So it is 5.5 to the power 20, and it is multiplied with phi of t tilde, phi of t tilde. So you have to integrate this equation from 0 to zero point 0.5 pi, right? So 0 to pi by 2. Um, so let's do that bit. That gives you 2.75. So x of 20.5 pi is x0 times 5.5 to the power 20, and phi of t tilde, which is 0.5 pi, turns out to be 2.75, right? So you know a lot in the you because it's a periodic system. You know what is happening here only by analyzing this bit and the fact that how many time periods are required, so the n, and with that knowledge you can say what is happening so much down the future. That what you can do using periodic systems, right? So that's more about the significance of what we did in the last lecture. Okay, all right, thank you.